My name is Douglas Mauro, founder, senior engineer at TruePath Technologies, and today I'm going to be talking about demystifying SNMP. Just a quick introduction on who is TruePath Technologies, and basically a little over 10 years I founded the company in the United States, New York. First thing I have to say is not New York City, everybody thinks that. Actually West New York. And we specialize in configuring and maintaining customers' monitoring tools. And CheckMK is one of those. And so that is really what we do, is we focus on just the monitoring. And a lot of those folks out there, sitting in the audience can attest to the fact that a lot of times the monitoring might be secondary or third. Customers are out there trying to put out fires, and sort of monitoring is an afterthought. And so my company is one of those companies that's all we do, is we just focus on that piece for the customer. We have a lot of big customers in the United States. Some of them you might recognize, like Comcast and Time Warner. Wegmans is a very big grocery store, but I don't know if you might recognize any of the other ones. A little bit about myself. Again, senior engineer and founder. I worked for Sun Microsystems for a little over 10 years. I talked with some folks about that. Very proud author of the O'Reilly book, the Essential SNMP. Make sure you ask questions later on. I love to do a little bit of software programming myself, and I enjoy exercising. I did the Ironman, competitive cycling, and I try to keep the office fun and upbeat. Let's see. That's probably enough about myself. So this is the agenda. We're going to go through all these different pieces here. We'll keep this open. If anybody has any questions along the way, please raise your hand. We'll go ahead and pass you the microphone, and we'll reward you for asking questions as well. So let's talk about what is SNMP. People always ask that. People ask me, non-technical people, my mom's friends, what is SNMP? Well, I'll try to explain it to you. And this is a quote. The core of SNMP is really just a simple set of operations. It really comes down to that. Forget about all of the MIBs and the protocols and things like that, but really what we're trying to do is we're trying to get two things, two devices, two objects in some sort to be able to communicate back and forth to each other. We want to be able to have them be able to retrieve information from the parent to the child, from the agent to the software, from the computer back to the user. And SNMP really is a set of operations that sort of is a common language for that to happen. And really it's supposed to be in the fact that no matter what kind of operating system that you have or what kind of hardware, that SNMP agent will sort of speak that language. And simple in the terms of, we want to be able to sort of just ask it, give me some type of information based on this very basic numbers and dots, or OIDs. And then in the end, when we get that simple information using that simple address, we're going to go ahead and use a MIB to sort of translate it and make it a little bit more meaningful. So it's supposed to be simple, but for those of you that have used it, it can be very complicated. I like to say it's almost like trying to boil the ocean, in that it really ends up being sort of a piece of the entire infrastructure. People say, geez, just like monitoring in general, right? In the beginning, monitoring was really just about networks. People say, we call up a customer, hey, are you doing monitoring? Yeah, we're pinging all of our routers. We don't need monitoring. Oh, okay, thanks. So when you get into it, this sort of simpleness to it becomes very complicated. So let's look at a typical management infrastructure here. Let's look at a traditional network management system, to where you have your sort of main system in the middle there going out and asking for information from all of your different devices. And they could be simple things like switches, servers, your applications, and then your users might get into the NMS through the web. So that's sort of a typical environment, right? You have this server going out and polling and getting information and doing all that good stuff. And then the user being able to see the graphs, the reports, maybe getting some alerts. You can get into a distributed NMS or distributed architecture. And in this case, what you have is you have your same setup on the right-hand side, but then what we have is we have over a VPN or a secure network, we have something out in London that is doing all the heavy lifting, doing the SNMP there. So what we might not want to have happen is we might not want to use our expensive network to monitor from Germany over to the United States and California. That's a very expensive line. If we start to use it for all these reports and polling, all the users will say, geez, the accounting is running slow. You're hogging up all our bandwidth. And so what we can do is we can put a sort of a full system in there, a distributed node out in your FAR application, your FAR location, and have it do the heavy lifting, have it doing things locally. And then from there, it just reports back the important information. So it reduces the load on that. And for that very high level, let's dive right down into the nooks and crannies here and talk about what is a MIB. Has anybody read a MIB file before? Has anybody opened up a MIB and looked at it? Yep. How many people have just gotten frustrated and just closed it and said, this is dumb? Who wrote these things? I still do that myself. And we'll talk a little bit about finding these MIBs. These sometimes you just fall over yourself seeing all these MIB files out there, and then there's other times where you just can't find that one MIB. You just can't find it for whatever reason. The vendor wants to keep it secret, and you have to have a support contract and all that. So we'll sort of find ways to work around that. But we talked a little bit earlier about that sort of simple code, that sort of simple address, and really it comes down to a bunch of numbers and periods. And so what we have here is at the root node, and here you can see that we have this sort of tree structure. And what we can do is we have numbers that are associated with that, 1, 3, 6, 1, 4, 1. And so that basically follows this tree down. And that allows us with SNMP to do things like get an entire leaf or root node and get everything underneath it lexigraphically. So we'll come down it through here and follow it down and get all this information, and then work our way back up. And when we've hit this and say, well, that's the end of it, then we can sort of be done with getting our information. But the way that a MIB works is that a MIB is a text file, and in the old days it was the RFC's request for comments, and it's in a certain type of format. And when you look into it, it gives the information that the agent should be supporting. And we're going to talk more about that later. Just because I know the, let's say, English language doesn't mean that I know every single noun and verb that is out there. So just because you have this MIB file doesn't mean that this device is going to be able to support it. Even if they say that it supports it, it might not be able to, it might not have the information, it might not be set up correctly. So the MIB file is a text structure that has a whole bunch of different syntaxes that are involved in it, and it's supposed to be the definition, it's supposed to be the blueprint for the information, and it's supposed to be able to synchronize with these numbers that the system uses. And when you load the MIB, when you bring the MIB, or when you put the MIB in with these numbers, you start to get some more meaningful information. Sometimes you don't have the MIB and you just look at all the numbers and the results. Sometimes you only have the MIB and you're trying to figure out what those numbers are. And we'll talk more about that in detail. So let's talk a little bit about polling versus traps. So we have the MIBs, we understand NMS architectures and layouts. The MIBs, in a sense, are the overall text documents that's supposed to be the architecture and a blueprints for our information. So let's just talk basically, how do we go out and get information? And there's really two ways that SNMP does that. And you can think of it as one-way or two-way communication. The typical way that we all sort of gather information is in the two-way traffic, where we go out and I say, how you doing? You say, I'm fine. Well, that's great. And then I do that every minute. How you doing? I'm fine. How you doing? I'm fine. And that's how we do that with our CPU monitoring. That's how we do that with agents and polling and whatnot. You go out, you gather information, and you come back. You do that with SNMP gets and next, and you get the tables, and you get all that great information. You get the performance data, and all is well and good. There's another way, which is the one-way, and that is SNMP traps. And in the beginning of SNMP, I think that there were a lot of people that felt that this was going to be a little more effective than it ended up being. What it means is that instead of having you go to your doctors every 5 minutes and tell your doctor that you're fine and paying the copay, at least we do in the United States, you go and you pay every single time. So every 5 minutes I'm going to the doctor. You say, you know what, forget about that. I'm just going to go and tell you when I'm feeling bad. The good and the bad of that is that if I tell the doctor the one time a year that I'm sick, that's going to be fine and good. The doctor will help me. We'll do some stuff. But if the only last message I have is I'm dead, that message is never going to get to the doctor. And the same thing works for network equipment. So you could be polling for temperature, and you could be polling and polling and polling, and say it's 100, 200, 300 Celsius, the thing is almost on fire, and then you know that there's a problem. Or you could just set an SNMP trap and say, when you're on fire, let me know. And of course, that trap will never get there. On the reverse side, you have now equipment done that takes it the other way and says, well, I'm going to send you a trap as much as possible. Think of the doctor now. I'm just telling my doctor, I'm writing a letter to my doctor every 5 minutes. I'm fine, I'm fine, I'm fine, I'm fine. And just like with NMS, you get all of these traps. So now we have customers that come to us and say, my God, we're getting 10,000 traps every minute. And I don't even know what they mean, and I don't know where to find it in the MIBs and the secret file and whatnot. And so a lot of times I find that people are trying to get away from that one-way communication and trying to get to the more of the two-way communication. Because you can also see that if something falls over, even though you're just looking for an application or CPU or memory, that if you can't poll for some reason, there might be a bigger issue. Could be something that you're not even able to poll for, like power or temperature, or that the thing is literally on fire. There's another piece within SNMP that I don't use. I think I've only used it when I was writing the book and maybe a couple times in demonstration, but I'd love to know, has anyone used an SNMP set in their lives? 1, 2, 3, all right, a couple out there. So basically an SNMP set, and I'll just take it very quickly, but in the MIB you can see that it's a read, write, and whatnot. It allows you to be able to, you can do an SNMP get for, let's say, location. It says, this switch is in Munich, Germany, owned by Douglas Mauro, boom. And you say, well, that's not right. That's not the right owner. That's not the right location. So let me do an SNMP set with the right community string, put it out there. Now you can actually write the information to it. A lot of people see that as a security risk, as you can imagine. Some people have put SNMP read writes for things that maybe they shouldn't have, like being able to reboot servers, being able to delete users, change passwords, and things like that. So in the beginning, it was like, oh, this is great. We'll be able to do everything with SNMP. And then security came booming down and said, my God, don't do that. So not a lot of people use SNMP sets, but it's out there. So when we talk about SNMP, people say, well, you know, what is it? Like, where is it? You said that there are all these, it's a simple set of commands, so what are we doing? What's the software that talks back and forth to each other? And then the question is, do we need an agent? Like, is there some sort of software agent that sits out on the hosts or on the devices or on the switches? or on my Liebert UPS or batteries. And in the old days, agent was a very popular and sort of powerful term because software manufacturers were coming out with software that was their agent, that you had to have their agent. So as an example, you had OpenView, and you had to have the OpenView agent. And then, of course, their licensing was per user, per agent, and whatnot. And so people will ask, well, is this agentless, or do we need an agent or not? And that question still comes up every once in a while. So the agent is really the software that sort of sits on the device that responds to SNMP. Same thing for the operating system, same thing for maybe your scripts that sort of can respond back to the NMS server. So when you have a Cisco, people say, well, do I need an agent? And I said, no, you don't really need an agent. Well, but doesn't it need the SNMP? Well, yes, but it's built in. So it depends on how you look at it, right? Same thing for your Windows operating system. Do you need an agent? Well, usually there's an SNMP agent that's on there, so you don't have to go out and get another agent if you don't want. But we'll talk about that. Even though something is SNMP compatible, for instance, the things that you can get with CheckMK are 1,000 times better than you could ever get with a Windows SNMP agent. So a lot of times you need to have that supplemental software or scripts or agents to be able to get anything meaningful from the devices that you're trying to pull. So in this case, the switches, the Ciscos, the routers, and all that kind of network type infrastructure usually included in it. Operating systems, you can find it pretty easily. And then you might have your own scripts, your own NetSNMP agents and whatnot that will allow you to interact with your software APIs. The other piece are, for instance, hardware devices like your Liebert units, your large batteries, generators. We don't sort of see those as network devices, but if we want to be able to pull them to say, tell me when you're on generator, tell me when the electricity is out, tell me when the battery is about to run out. Sometimes you need to get a little card. They put the card in, plug it into the Ethernet, and now you go out and you start pulling it. And with that, again, you don't need an agent. It's already sort of built into the card and the system itself. So this goes into what I was talking about with the software agents. Typically for network devices, it's already installed, it's already in there, you just need to be able to configure it. And what are some of those configurations? Well, we'll talk a little bit about like what are the different versions of SNMP. What are the hold on one second. Excuse me. So what are the different versions that it supports? And we'll talk a little bit more about the different versions of SNMP and which one's better and which ones sort of we should avoid. The UPSs, like I was saying, are more hardware that have the SNMP in it. Windows, you can grab the agents, and Linux, you can use the SNMP out there as well. So let's talk a little bit about what version of SNMP and what versions are even out there. So how many people have used SNMP version 3? All right. How many people actively use version 3 and didn't just screw around with it once? All right, that's even better. So I'll give you a very, very high level what SNMP 1 through 3 is. SNMP V1, no security. V3 has security. Everything in between is sort of gray. V2 out there has the ability to, V2 has the ability to do more gathering information in larger quantities, being able to do bulk. And with V2, back in the days when people didn't really have network management networks, sort of everybody was all on the same network, people really got nervous about being able to look at the type of information, especially think about when the idea that we might be setting information, SNMP sets. You could do a simple TCP dump be able to look at that information, because none of this V1, V2 is encrypted. So you could very easily, within a college that sort of was all on one network back in the days, could do a TCP dump and be able to see that kind of information, to be able to literally see stuff coming back. And then the issue too becomes is that they may not just be getting the network statistics. You really don't know in the beginning, and even now when I run SNMP walks in some agents, I don't know what the heck I'm going to get back. You do an SNMP walk from beginning to end, you get like 15 volumes of information. Well, back then that could have been students' codes or passwords or records and whatnot. So that's why sort of version 3 came out, is that it has the ability to have encryption in it, has the ability to be able to break things out and be able to segment the information a little bit better. Sometimes people say, all right, well, what version is the best? So that's the question. And the answer is you might not have a choice. You might, hey, I'm going to go version 3. It's going to be the best. We're going to lock it down. It's going to be great. Well, the issue is that your device doesn't support version 3. Your battery backups, your old Cisco's that you just inherited, your 1,000 network devices don't support version 3. So you're now going to be on version 2. Well, the good and the bad is that even though version 2 and 3 can be seen as the same as security, the question is do you really want to push for V3? And I use this analogy here where, would you put a padlock on your car door? You already have a lock. Would you put another lock on top of it? I mean, why not? Literally, like, why wouldn't we do that? Extra security, right? People could break the door. They could get my first key, but they won't get my second key. It goes on and on. So there really isn't anything bad with that except for usability, except for the fact that it's going to slow me up on a day-to-day basis. And that when you get into the version 3, when I talk with customers and I say, well, what else is on this network? Because it's a dedicated network, right? You have your accounting, you have your billing system, you have all this other stuff unencrypted sitting on there. Why do you want to put the CPU load of encrypting and decrypting on all of your devices? Why do you want to make it more complicated? The SNMP version 2 configuration couldn't be any easier with just a community string and maybe a host entry. But with version 3, it's a little more complicated. So when you get into troubleshooting it and you get into day-to-day use of it, if you don't need it, why put that extra layer of security on there where every time you go in your car, you're going to have to unlock it and troubleshoot it? So what version is the best? It really depends on the environment. It depends, and I always say to folks that really think about it if you really need that extra level of security or not. Sometimes it just gets in your way. So this is an interesting slide here. So let's get back to talking. Oh, by the way, does anybody have any questions so far? Okay. If you do, raise your hand and let me know. So we talked about the MIB files as sort of a blueprint, right? And if we think about really what a blueprint is when I look at a blueprint, it says that this room should be here, and it's connected to this room, and on this floor, we have 2 bathrooms and 1 dining room and 1 family room sort of set up here. And I can take that blueprint and I can walk around in this building, right, with this blueprint, and I can use it to sort of navigate, and it makes sense, right? I can throw away the blueprint and still walk around. I could take the blueprint across the other side of the world and still look at it. All right, you have to sort of follow me here with this analogy, and I hope it's translating okay. But basically, if I have a MIB file, that's a blueprint, that matches, let's say, my Cisco device, those two are going to match and it's going to make sense. On the MIB file, it's going to say that the first thing is the CPU, then the temperature, then the ARP table, then all this good stuff. And when I ask the Cisco device for it, it's going to spit that information out. Then my software is going to tie them together, because it's going to get a bunch of numbers back, and it's going to use that blueprint as a translation table, and it's going to print it back, and it's going to say 136.141.26593 CPU 5-minute average equals this. But just because I have a MIB file, just because I have this map, does not mean that it's going to work in every situation. So just because I have this blueprint, I can't go to my house in the United States and say, well, why isn't there a bathroom here when it shows it like that in this blueprint, it shows it. And it's because in the device has its own sort of MIBs that it supports. And there's really no way for us to find that out unless you just do a walk from beginning to end, which is a lot of times what we do. It says it supports version 2, it supports version 3, and MIB RFC 1213, it supports all this, and that. But you really don't know until you walk that MIB from beginning to end. So just because you have this MIB file, just because I have this Cisco MIB file that's about environmentals, and it shows me these numbers, and I try to pull that Cisco device, and it says object ID not found. People say, well, why doesn't that work? It's because that MIB file doesn't work in every situation. With that said, though, you can never take away the actual physical entity of it. You can't take away my house and the floors that I have. You can't take away the architecture that's in this building, and you can't take away the architecture that's built into the Cisco agent. You might not know what's in there, but through the powers of SNMP, you'll be able to walk it from beginning to end and discover the entire thing. Now, you may get back only numbers, but at least it's a beginning, and I'll show you in a little bit how you can take those numbers and sort of reverse engineer it and get the MIB files for it so that you can find the blueprint, so you can make sense of some of those numbers. So typical data collection that sits out there is that we have a NMS that sits in the middle of all this, and we go out into the different pieces of environment, different pieces of gear, and we need to look at the actual flow of it. So for switches, you may be getting interface stats, port statistics, you may be looking for drops, and we're doing that two-way communication. The users will be coming in through the web applications on the operating system like disk, memory, CPU. Those are also pieces that are flowing. But then you get into things like the voice over IP, MOS, and jitter. And some of these VoIP may have what's called internal polling. And what that means is, well, has anybody dealt with Cisco IPSLA? All right. Cisco IPSLA is almost like, and I'm a big analogy person, so it's almost like going back to that doctor where I keep talking to the doctor back and forth. But instead of talking to the doctor, I'm going to talk with a nurse locally. And then every once in a while, the doctor will talk to the nurse. So it's not so much as a proxy, but think of it as two Cisco boxes talking back and forth to each other. They're doing the polling, not the NMS, but the VoIP is actually working back and forth, and it's pinging things, and it's testing it, and it's looking at the quality of the line, and it's looking at the drops, and it's doing all this stuff, talking with the cell towers, looking at artificial traffic that it sends to the users to see what kind of information it's coming back. And then when it gathers that information, the NMS machine will go to it and say, hey, tell me what your VoIP score is. Tell me what your MOS score is. And it gets that information through SNMP. But the VoIP machines may be doing some internal polling. So when we talk about data collection, there's a couple of different ways to do it. There's this notion of a simple get. I go out there and I say, I want to get the temperature of CPU number 1. I go to that machine, I say, give it to me. It comes back with a simple string. Hopefully I've got the MIB file and it tells me that it's a Cisco CPU, temperature 98 degrees. If I have to do that for all of the interfaces in a switch, that's going to be a lot of information. It's a lot of two-way communication. Think again about driving to the doctor. Driving to the doctor, telling them your temperature, you come home. You go out to the doctor, you tell them your weight, and you come home. And all this back and forth, all this payload, all this overhead, all this beginning and end. So what we have within SNMP is the ability to do get bulks. So it's sort of like saying, again, using the doctor analogies, where when you go to the doctor, you're going to give them all this information, a whole set of it. So there's going to be one drive going to the doctors, getting all the information, and then coming home. And that's exactly what a get bulk does, is it tries to get as much information as possible without asking it over and over again. An SNMP walk is the notion that, using the building analogy, is I'm going to walk into this new building I've never been at before, and I'm going to go into every one of the rooms one at a time. I'm going to go into this room, back out, that room, back out, this room, then the next room, all the way out there, come back in. That's exactly what a walk does, is it literally goes and it tries to lexicographically walk the entire agent or the entire tree that you may have given it. And these are the sort of simple commands that you would give as a user, as software, to the agent. So here's what we use. So those people that have used SNMP are sort of just briefly seen it. This is usually what we end up with. As you do the big walk. So here's an SNMP walk minus v2c, giving it a community string of public, giving it the IP address, and then the infamous object ID, 1361212 or something like that. And so what happens is now we've gone out and I've started with 1361212, and that's sort of like saying 1361212, that back door. Now go and walk everything through there and go all the way around and give me all that information back. I don't have a blueprint. You see I don't have a blueprint here, so I'm only going to get back numbers. I'm going to get back numbers and information here. It's still useful, in a sense. But I have no idea what this counter 32 is. Is that the number of people in this building? Right? No idea. Is that the number of beers we're going to drink this week? That would be a lot. That would be impressive. Or is that the number of deaths from beers we're going to drink? I don't know. So when you look at that, you're going to get this information back. You're going to get it. And a lot of times, this is what we sort of have to do to sort of just discover the different areas and the different MIBs that are out there. What I do now is I can run that same walk. So this is sort of the before. I get all these numbers, and they don't mean a lot to us. And I saw all these, somebody reported back, hey, there's rooms over there, and there's this, and there's a bathroom and a kitchen, and you're like, it doesn't really make sense to me. Or really, they don't even know if it's a kitchen. There's just rooms and blocks. So now if we look at it, now if I put that blueprint together, if I put that MIB together with the same walk, and how do you do that? Well, when I run the command SNMP walk on my Linux machine, there is a directory where you can put all your MIB files in. And there's some software which we'll talk about, which I'm sure a lot of you have used, the Net SNMP. It's sort of the de facto on the Linux side. And you say with the -m, here's the location, user share SNMP MIBs, and which ones do you want to load? In this case, I just said all. I'll load them all. And now look at the information that we have. Now it makes more sense. And to be fair here, I only looked at one interface. So here I can see that my description is port 1. Now I can see my speed, my admin status, my operator status. And back then we thought those beers we're going to drink, those are actually the unicast packets, number of discards, octets in and out. So this is the real information. This is what we would use. This is what you would actually, when people want, what's the interface stats? What's the throughput? this is exactly how you get it. This is where you get the octets in and out. And so what you could do is you could literally then just put this, which is translated into words, or you could put just the number in there and pull for that number and get that interface stat. And you could just do an SNMP get every 5 minutes and get that information. And 9 times out of 10, that's exactly what NMS machines do. So as an example again, before MIBs, sort of ugly, but we get the information. Afterwards, we get this. Now, what happens sometimes, and the issue is that light, I don't even know what time it is, so I don't know if I'm running over or under, so I can't, oh, there's a clock there, 11:30, okay. So I think I have 15 minutes, right? Yes, no, good. What happens sometimes is that you will do this, and you'll be polling and be like, oh, this is great information, I'm getting this, and that, and the next thing you know, it changes into here, and you're like, ugh, now I don't know what it is. So you'll sort of, half of it will get translated, and the other half won't. And I'll show you how to basically take those, and it's as easy as using, there's this new tool online, and I'll write it down if you forget it, but it's google.com. And basically, you know, what you can do is you sort of just start putting in these numbers and sort of start backing them off until you get to the full MIB itself. So it might be 136.141.2789. And when you look up into Google, then you'll see, oh, that is a Cisco. There's the MIB. You go find it, and you download it. You put it into your directory, and you go do the SNMP walk again. So that's a big thing, is when you end up with these numbers, the question is well, where do you get them? You know, where do you find it? And the big stink that I have with vendors is that sometimes they feel that their MIB is a proprietary piece of software, intellectual property. Some ways it is, but I've already purchased your hardware. I'm trying to interact with it. I'm trying to use it. To me, I see MIBs more as a user manual. If I purchase a car, you should be able to get the manual for it. And so what happens is that sometimes you have to go to the vendor. Sometimes you go to Google, right? Brocade is 136.141.1991. And if you put that in Google, you'll come back and you'll see Brocade, and you'll see these other tools and whatnot, and then you'll be able to go down and be able to find that MIB. But a lot of times, you may just see that it's this particular vendor, like Ascidian or a Calyx. Cisco's, there's a bazillion out there, and you'll get tired of going through their MIBs. They do a great job of it on the other side, where it's almost too much information. There are a lot of online tools where you can find MIBs. These are sort of my little stash of links. Cisco's Object Navigator, and I did a shortened URL because it's a little bit longer, but if you just Google that, you can find it. And it's a nice little tool where you can go in and be able to look at the, if you put in 136.1.212, it'll sort of tell you, oh, that's the interfaces, and you can sort of start walking around and be able to explore that. Then you just get into places where people have MIB repos, where people are just dumping MIBs, and I have these 3 that I use commonly. And usually these are the 3 that come up when I put the object ID in there. These are the ones that come up with MIBs. One thing to note too is that a lot of times companies will say, oh, we're SNMP compatible. Like, oh, okay, great. You know, what does that mean? Well, that just means that they're going to give you your interface stats in and out. Well, but this is a firewall. I want to get more information. This is a you know, battery unit. You know, I want to know when there's a power module that fails. Well, this is one of those things that takes a little bit of discovery. And so I always encourage customers to get involved, the network monitoring, the enterprise monitoring teams, to get involved in procurement, because it's very important that somebody goes and buys all this gear that's very difficult to manage. They say, oh, but don't worry, it's SNMP. Well, yeah, it's SNMP v1, and all it does is traps. So, you know, so now we're just going to get 60,000 traps every minute. right? So it really is worth it to look at the equipment, look at the software, look at the devices that people are buying, and also be able to look at their MIBs to see what kind of information, because what's happening now is sort of vendors are getting a little lazy. In the old days, the traps were really useful in that they said, this is a trap for interface up. This is a trap that I'm on fire. This is a trap that says user has logged in. And this is a trap that the threshold has gone high. Well, a lot of times now is they say, well, yeah, we have traps. And there's just one trap. It's called the alert trap. And you're like, ugh. So here, there's the alert trap. And so what happens is now it's very difficult then to set actions based on that, because you have to start looking at the strings. And because it's based on the firmware, right? The firmware of the device, the software of the device, that may change without you knowing it. So before in the traps, you may be grepping for the word temperature. Well, now it's not temperature, it's now temp. And it's lowercase t, not uppercase t. So it becomes very difficult, and those are the kinds of things. And we deal with that with customers that say, hey, will you come in here and, money's no object. We got all these things, and, all it does is traps. We're like, well, there's no way we'll know what traps to come in. And we can't guarantee you that when you upgrade to the next version of Calyx, that these will even work without a huge amount of regression testing. It's very ugly, very time-consuming, and 9 times out of 10, it doesn't even work. So here's a great one. Just give me the software. People are like, all right, I'm done listening to you. Just give me the software. We're technical people. Let's have some fun out there. There's a lot of cool tools out there. You can download them online. The big one for me is SNMP RRD tool. A lot of people have used Cacti. Who has not used Cacti? Come on, that's a huge one. That's a big one that sits out there. One thing that I do want to say is that when you get into the graphing world, you get into the Cacti world, you'll start playing around with RRD tool. How many people have used RRD tool? Right? Round robin database. How many people have tried to explain data consolidation to somebody? My God, it takes I love that. Why don't I see as many dots in my month as I do in my years versus my days? It's a great tool. If you haven't gotten into it, it's a great ability to store information. There's a lot of fun examples out there. There's some examples in my book that sort of show how to be able to push stuff and grab it, grab the information and then put it into the round robin database. But the thing about RRD tool is the ability to be able to graph as well. So one of the big takeaways here for today is that SNMP is the one that I've been showing up here, open source. You can go grab it. It's used within the book. And you can start doing your SNMP walks and polls and all that good stuff. What else did I want to say about the RRD tool? Is another open source software tool. And that isn't really for SNMP, but you'll see that a lot of monitoring products out there will use our RD tool because of the ability to not only save data in a non-growing database environment, but also the ability to produce graphs in a very fast and efficient manner for the web. So I'm going to go ahead and take questions. I'm going to force people to have questions. Go ahead.
Hi, do you have any graphical tools to do the SNMP walk that you use?
Any reference tools?
A graphic tool, so instead of having to do an SNMP walk via the CLI, do you have any tools that you use personally?
Okay, a good question. So there are what are called sort of MIB explorers, MIB walk tools. There are some open source ones out there. I think SolarWinds has a free one. There is one from Tivoli, the MIB Explorer. And the big one that I usually use is called GetIf. And I actually need to take a note to put that in these slides because that's a good open source tool. It's GETIF. and that allows you to put other MIBs in there as well. You can do a little bit of graphing, but it's nice to just be able to walk a device and put that in there.
I've been using from Manage Engine. They have a pretty good tool that allows you to do the same thing as with the CLI, but they do it graphically, and you can make that tool search for you in multiple MIB files. So it's quite easy to find this MIB file has the right OID in.
Good, okay. A good question. Who else has got one? No, I was just giving a book. That's the question. Thank you. All right, now we're going to get questions. Go ahead.
Hello. Well, my question concerns the way that, is there any way that I can ensure that my MIB is valid from an SNMP request? So, like some kind of information that the SNMP answer submits to me that says, okay, I'm version whatever, you know, the information has to be there. There is an SNMP agent built in or whatever running on the system that I'm targeting with my SNMP walk. Is there any information that lets me know that a given MIB fits to what I'm getting? Like, for example, an agent version.
Yep, good question.
Thank you.
So let's use this example, right? Thank you very much. Yeah, thank you. So that's a great question, and it really goes into, and I have 4 minutes, I think, before I have to go. I just saw looks and I thought, uh-oh. I'm minus 7 minutes? Over 7, okay. All right, so I will quickly address this. So the answer to your question is, unfortunately, no. No, there's really no way to know. Cisco says to me, hey, we have this device, and it supports this particular MIB. And I go and I get the MIB, and I do an SNMP walk on it, and it comes back, and everything works, and it's all fine and good. But now somebody else, your friend there, says this other Cisco device supports the same MIB, don't worry about it. And you may even have a PDF. You may even talk to their technical people. But then when you go do an SNMP get on it, it comes back and says, object ID not found. But it's a Cisco MIB. This is a Cisco device. And it might even be the same device, but it's firmware 1.1 and not 1.0. Right? Just because it's newer doesn't mean it supports it, like anything. Sometimes software takes things out and they break things. And so there really isn't a way to know that. And that can be very frustrating too, especially when, you know, they say it's SNMP compatible, you go grab a Cisco MIB and it doesn't work. And so sometimes you just have to walk it from beginning to end, look at the numbers, find what those MIBs are, and then see what it is. Instead of starting with the MIB saying, hey, this Cisco is going to support this. No, that doesn't mean that at all, even when everybody says it should. That's a good question. I think we got time for 2 more questions, or are we done? Oh, all right. You know what? Here's what I'll do. I'll say this. I'll go ahead and close it up. I'll take the 2 questions. I got 2 mugs here for you guys to come up and ask questions, and then everybody else can break. Is that fair? Thank you very much, everyone.